calculators out because your calculator is going to be very, very useful to you today. All of what we're doing can be done on your calculator pretty easily. Okay, we have CP11 today. Ladies and gentlemen, if you have x to the third times x to the fifth, what do you get? X to the eighth. X to the eighth. How do we get 8? You add the exponents. So adding exponents is an option. So we can add exponents. If you have x to the seventh divided by x to the fourth, what do we get? X to the third. How do we get third? We subtracted the exponents. So we have two options today. You're either going to add the exponents if it's a product, or you're going to subtract the exponents if it's division. Ladies and gentlemen, welcome to today. Okay? So here we go. Example 1. Use properties of exponents to simplify the expression. Those are the directions you should definitely write down. Assume variables are positive. It's just a little, hey, I'm going to make it a slightly bit easier for you. We're going to just assume all the variables are positive. So you don't have to write that necessarily. All right. Use properties of exponents to simplify the expression. So we have x to the negative 4 times x to the 8th. They have the same base. What do we get to do to their exponents? Add them. We're going to keep the base the same. What is negative 4 plus 8? 4. Done. Add your exponents. Negative 4 plus 8. All right, this is interesting. What are these things? This x to the 2/3 times x to the 1/5. Fractions. Yes. The same rules still apply. This pertains to what we did on Friday. If you remember, if I have x to the 2/3, it has a special meaning that involves a radical. What goes here in the index? The 3, and then you have x to the power of 2. All right, so this was when you had that rational fractional exponent. It was power over index. Power over index, where the n is in the little elbow there. That's an n. You can't really read that. All right. But the same rule still applies. What do we get to do to the exponents? Add them. Same rule. Add the exponents. Well, if I want to do 2/3 plus 1/5 to add the exponents, what do they need? Common denominator, ladies and gentlemen. Common denominator, which is why I gave you that big old fractions worksheet on the first day back. Remember that? What is the common denominator between 3 and 5? 15. So we are going to multiply the first fraction by 5 on top and bottom, and the second fraction by 3 on top and bottom. So that gives me x to the 5 times 2 is 10/15 plus 3/15, which is x to what power? 10/15 plus 3/15 is 13/15. There you go, and that's a great answer. All right, same base, add exponents. On letter C, we have the same base. What are we going to do to these exponents? Subtract the exponents. Yes. We're going to keep the base the same, and we're going to subtract top minus the bottom. Negative 5 minus the negative 4. Top minus the bottom. What happens when you have minus the negative? Turns to positive. So that's negative 5 plus 4, which is negative 1. All right, so here we have one little rule. I'm not allowed to have negative exponents as my final answer. Does anyone know what a negative exponent does? It makes it a fraction. Yeah, we talked about it on Friday. That negative exponent wants to take my little base and the exponent and move it down. So it becomes a fraction, 1 over x to the now happy 1, positive 1. Okay? So 1 over x, or 1 over x to the first. So if you have a negative exponent, it's just going to move down into a fraction, down into the denominator. All right, again, we have the same base. What are we going to do to these exponents? Subtract them. So it's 1/3, and I heard the common denominator part, so we will do a common denominator. We're going to do 1/3, top minus the bottom. 1/3 minus 3/4. They do need a common denominator. What's the common denominator? 12. So I'm going to multiply the first fraction by 4, top and bottom. And the second fraction we're going to multiply by 3, top and bottom. That becomes 4 over 12 minus 9 over 12, which is x to the positive or negative? Negative 5/12. What's the problem? It's a negative exponent. And what does that negative exponent do? Drops it down. That's why I draw the little arrow down. So it becomes 1 over x to the 5/12. So that negative exponent just drops it into a denominator. Okay. Adding exponents, subtracting exponents. Here's the best part. You have a calculator. You can just type in 1/3 minus 3/4, and I get some crazy decimal. What do you do about that crazy decimal? Fraction. Turn it to a fraction. You can math frac, or on the Casio, it's just a fraction decimal button. And that's where we have the negative 5/12, which you can't see. There it is. All right. So you can convert it from fraction to decimal really easily. And so, yes, you could absolutely use your calculators. All right. Okay, that's great. We can add exponents. We can subtract exponents. This looks a lot harder, but it's the same thing. Example 2, simplify the expression. The only difference here is that they gave it to us in radical form. I don't like radicals. They're actually much harder to work with. So instead of radicals, we want to rewrite them as rational exponents. So letter A, we have the cube root of A. I see that the n is 3, but what's the power on the A? 1. Yeah, there's nothing there. You can put a little 1 on there. So it's a power of 1. So I want to rewrite that. The cube root of A can be rewritten as A to what power? Remember, it's power over index. So what should I write? A to what? 1/3. And here, the 9th root of A squared can be rewritten as A to the 2/9. 1/3 and 2/9. They have the same base. What should we do if they have the same base? Add the exponents, sure. We're going to add those exponents together, but they need a Common denominator. What is the common denominator? 9, yeah. So I just want to multiply that first fraction by 3. Whoops. So that gives me a to the 3/9 plus 2/9 is a to the 5/9. And that's a lovely answer. What is this thing called? Square root. So what number is in the index? 2. It's a square root, as in x squared, x to the second power. So this is a square root. You don't see the power there, it's 2. So I can rewrite the square root of x to the 4th as x to what power?
2.
Yeah, it would be 4 over 2, but that reduces. What is 4 divided by 2? Just 2. And I'm going to leave it 2 over 1. Times x to the, what can I rewrite this radical as? Power over index, 2 over 5. What are we going to do to their exponents? We add them, but we need a common denominator. So I'm going to do what? Multiply by 5 here, top and bottom. So we get x to the 10/5, 10/5, plus 2/5, which is x to the 12/5, which is a great answer. Are we adding or subtracting exponents here? Subtracting exponents, sure. So again, let's just change the form. The 4th root of a cubed can be rewritten as a to what power? A to the 3/4. And then the 8th root of a cubed is really a to what power? 3/8. And so now what do we get to do to those exponents? Subtract them. 3/4 minus 3/8. We're going to subtract the exponents. What do they need? Common denominator. So I'm going to multiply by 2, top and bottom. That gives me a to the 6/8 minus 3/8, which is a to the 3/8. And again, this is totally something you can do on your calculator, because I can just do 3/4 minus 3/8. Fraction, convert to decimal, and I get 3/8. Okay? So you can do it by hand, or you can use your calculator. I don't care. All right, what's in the index here? A 2. So this is the square root of y to the 5th, which I can rewrite as y to what power? 5 over 2. And, ooh, this is y to what power? Y to the 1st. So what's the fractional exponent? 1/3. There you go. So again, we're allowed to subtract these exponents. That's going to be 5/2 minus 1/3. Top minus bottom. 5/2 minus 1/3. What's the common denominator? 6. So I'm going to multiply by 3 on the first fraction and 2 on the second fraction. That becomes 15/6 minus 2/6, which is, y to the 13/6. y to the 13/6, which is the fine answer. Okay. Do you guys have any questions for me? Right. You guys have CP 11.